We have our decoupling capacitors placed, and let's get the power circuitry done. So I can click R to rotate. See, how do we want this? 5 volts, ground. I guess something like this will work. We can also, I think this might be a good placement. So we have 5 volts coming in, 3.3 coming out. Let's place the capacitors. And let's place those very close to their corresponding pins. Let's move some of this ref designators out of the way. Okay, let's save and let's take a look in the 3D viewer. Okay, RST, let's add the no connection flag. I noticed it was complaining. Let's update the schematic. Close, great. We can even move this a little bit closer. And if you find these gray texts annoying, I guess you can remove them by pressing the front fab. It cleans it up a little bit and if you're just worried about placement, you can even remove the silk screen text. Okay, so that's our power segment. We have our test point for our 3.3. So where do we want to place that? Maybe right out of the 3.3 gate here. We also have a test point here for our 5 volts. We might just put that here. Okay, so that's our power segment. Let's do our switch. It'll sit close here. We might put it like that. Next we have the LEDs. Maybe put that here. Bottom right. Okay, so here are the control pins. Alright, so we're gonna run here. Let's place the resistors. Okay, so we need to look at how we're gonna route this, because things might be tangling up here a little bit. Also, the LED is gonna run on the 5. It's gonna run on the 5 volts coming in there. Let me just quickly route the tracks just to see how bad this will tangle up. Okay, let's get some test points out first. Let's just place everything. Okay, so that test point goes here. That's a big test point for the little control track here. So we might actually remove these test points. They're a little redundant. And let's update the PCB. Okay, delete footprints with no symbols. That's where we gotta check it. Great, okay. And that's one last component we've got to place, and that's our test point here. I would like it somewhere here, actually. So I just noticed one thing also we have to change in our footprint, and that will be the pinouts. So we have 1 and 2. So let's take a look at the 3D model. These are going to be 1, 1, 2, 2. So let's just get that fixed. So go back to the menu, back to the footprint editor, my project. Here's the button, double click. So this one's going to be 1. Pad number 1, pad number 2. Okay. Let's save that, and let's save, and let's update the PCB. Close. Actually, let's remove that, and let's update again. Now we have the switch, yes, with 1, 1, 2, 2. Let's just rotate that, perfect. So we can see that our general outline has shrunk a little bit, so we can compress everything together. Let's put the resistors very close, maybe something like that. Okay, so it has shrunk by quite a lot, so let's tighten up our board outline a little bit. Let's go to 3D viewer. So this is what we have so far. We might have to add our 3D model again. It disappeared when we... Okay, perfect. Let's save everything back into 3D viewer. So this is what we have so far. Let's see if we can add the LED model as well. Products, IN, could be this one. Let's keep searching. IN6TAT, it's TBT. It's this one. Details, here, 3D step file. So usually the manufacturer has everything about their product. So let's rename this RGB Innolux IN S66 TBT RGB. There you go. And let's go back to the footprint. 3D models, plus add a new path. And that is our step file. Okay, so here it is. We might have to go even finer. Something like that. 2 points. So 1.5, 6, 7, 8, 9. 1.9 seems to be good. I think we have successfully placed it on our footprint. Let's save. Let's go back to the 3D viewer. Yeah, it looks right. Okay, so this is our PCB for right now. Here comes the tricky part, the routing. So I like to start with the power, so the 5 volts. One thing I've noticed though is how off the footprint is. So we might have picked the wrong footprint to see. It should be going down that way. So I'm not entirely sure how that got off sync like that. So here we have top to bottom after our ST-Link V2, but it'd be 1, 2, 3, 4, 5, 6. Okay, this is the one we want, odd even. Alright, and let's just quickly edit the symbol to look like our other symbol. So I'll just remove these. And let's add reset, place that here. Let's give ourselves some more space. Then we have SW clock, we have swim, SWDIO, 3.3, and 5 volts. Okay, save that. All the pinouts are the same, which is good. Okay, now the pinouts should be correct. Let's go back here, delete footprints with no symbols, update, and you just have to assign a footprint here, pin header, yes, that's the one, and let's update. Let's press OK, save, and now let's update. Yep, there we go. Now the pinout on the symbol schematic matches the footprint on the PCB. So let's start routing power. Now you can choose the thickness of the trace. So right now it's 0.25. And 0.25 traces is fine. If you want in inches, you can do 0.254 or 0.3. So that'll be totally fine. Let's continue down our 5 volt path. And what'll come out is 3.3 from our IC. But let's connect these two together. And let's draw. Okay, that completes the 5 volt nodes right there. Let's continue with our 3.3 then. Something along those lines. And we need to drive our 3.3 as well. So that could be one path for your 3.3. Okay, next we should probably look at the communication signals here. Fairly straightforward. They have to get to this path right here. Unfortunately, I can already see, so let's just click on one. And okay, so it's blocked by the 5 volt path. Now, instead of going to the bottom layer and to go underneath, like so, there's probably another way to do this. And I'm thinking we route our 5 volts all the way around. So let me show you what I'm thinking. So let's delete this trace. And let's do these two straightforward. Let's just add them like that. Even then they will tangle here. Okay, actually that works. Let's give ourselves some more space here. I don't want the two traces to be too close, since one is a clock and the other one is the data. Okay, so now they actually connect without having to go into the ground plane. Let's see if we can get the 5 volts in now by probably going around. Okay, that actually works. It's a bit of a windy path, but it works. Okay, let's give ourselves some more space here. We don't want to be on the edge. There we go. Might tighten up here a little bit. Okay, I like this because we don't have to go underneath anything and break the ground plane just yet. Not for the sake of the power and the data signals. Okay, let's take a look at the LED circuitry then.